This is the tutorial for Algebra Study Guide quiz number 18. So let's take a look at some of these problems that we'll see on this week's test. And so first problem, it says factor completely. So I want to look for common factors. I don't see any. So this is a four-term polynomial, so I'm going to end up factoring by grouping. And I make sure if that third term's negative, make sure that you group that sign with that term. So I changed it to plus negative so I really see what that sign is. Now I see a common factor of x squared between both of these terms. So I'm going to pull out the x squared, and what's left over is just an x, not a 3, but an x plus 5. And taking a look at the next term, I see a common factor of negative 4 because I want to make an x plus 5. And if I pull out just a positive 4, I'd have the wrong signs. So when I pull out a negative 4, both signs switch and I've got x plus 5. So now I can go ahead and pull out the x plus 5. So I'll put that on the outside of a set of parentheses, and when I go ahead and factor, I'm left just with the x squared minus 4. So it says factor completely, so we always have to look at that one of those binomials. In this case, this binomial right here is a difference of squares. And so whenever you factor and you've got a binomial left, check to see if it factors one more time. If it's a difference of squares, it will. So this factors to, still have that x plus 5, but the x squared minus 4 factors to an x minus 2, x plus 2. And that's going to be the form I'm looking for. So looking at the next one, factor completely again. Look for common factors. I see a 2 goes into each of these terms, so I'm going to pull out the 2. I'm left with 4x squared minus 8x plus 3. So my strategy on factoring this is looking for the prime number. And the prime number that I'm going to look at is either the first or last term. In this case, I have the last term being prime. So I know 3 and 1 are the only numbers that multiply to make 3. I also know the signs because this last term is positive. So the outside and inside terms add to make negative 8. So to make that the case, if I go ahead and try a 2x and a 2x, this should work. So let's see if it does. Negative 6x, negative 2x. Yes, those do add to make negative 8x. So it does check out. So I've got the 2. Don't forget about that 2. Sometimes people will forget that. You won't get full credit for the problem if you don't write all the factors down. So let's take a look at the next one. No common factors. This time I'm looking for numbers that multiply to make 4. But the outside and inside terms are subtracting to make 5. So my guess is that I need to probably break down the 6 to 2x and 3x. I do want one of the factors to be bigger than 5, but just not that much bigger if I multiplied by 6. So I'm going to try if I go with a 4 here and a 1 here, this should work. Let's see if it does. 3x and 8x. You see, those will subtract to make 5. Now, in order to make it a negative 5, I need to make 8 negative. So to make 8 negative, I need 4 to be negative. To make 3 positive, I need a 1 to be positive. And that does end up working out. So again, the factored form 2x plus 1 and a 3x minus 4. So looking at the next set of problems, on this one here, we are trying to find the possible linear dimensions for the rectangular prism. So the first thing I'm going to see is a common factor. I'm going to take out that common factor of x. So when I put that on the outside of a set of parentheses, I'm left with 15x squared plus 52x plus 32. And so now I can go ahead and factor it again. No common factors here, so it's going to factor as two binomials. I know both signs are addition inside the binomials because they multiply to make a positive, add to make a positive. Now, 52 is not much bigger than 32 and 15. 32 and 15 have some pretty decent sized factors. See, 5 times a number is going to make the number pretty big, so I think I need to break it down to 5x and 3x. Now, factors of 32 would be like 2 and 16. Pretty sure it's not 1 and 32, but that could be it. The other factor I think it's going to be is 4 and 8. So I'm going to try the 4 and 8 first. And again, you just tried both ways to put the 4 and the 8 in. I'm going to put the 8 here and the 4 here, and let's see what happens. This makes 12x. This makes 40x, and you see how those will add to make 52x. So it's a trial and error. The strategy is mainly just looking to see what kind of signs we were going to end up having, and thinking about if numbers add to make 52, just make sure they're not bigger than 52 when you come up with those factors. So when we write this answer, we're going to write it as, since they want the dimensions, x units. We'll go 5x plus 4 units. Put some parentheses around there to show that that is one number. And the last one was 3x plus 8. And then I'll put some parentheses around there and then units off to the side. So those are the dimensions of that rectangular prism. Let's take a look at the next one. I see perfect squares here. So whenever we have perfect squares, that tells us that we should try to see if it's a trinomial square. And if it is, that means both binomials will be the same. So to make them the same, I'm going to take the square roots of those numbers. So 4x squared, square roots would be 2x and 2x. Square root of 9 is just 3, so let me fix that. So I should have 3 and 3. 2 minus signs, because they multiply to make a positive, I had to make a negative. Now just check your inside terms and outside terms. Check to make sure they work out. Both are negative 6x, so yes, they make negative 12x. So 2x minus 3 quantity squared is the answer. Well, the next one's a binomial. So whenever you've got a binomial, check to see if you've got a difference of squares. And this one is a perfect square. Both numbers are perfect squares, so we can go ahead and factor it at this stage. And we got one minus sign, so it only works if one is negative. Otherwise, we would have a sum of squares, and that would not factor. So 5x and 5x make 25x squared. 4 and 4 make 16, but to make it negative, we need to have opposite signs. And that's what cancels out the outer and inner terms, is that they're the same number, but opposite in sign to make 0. So you can see how that cancels out. So make sure you write them both, 5x plus 4 and 5x minus 4. So now on to the word problems. First one is a movie ticket problem. Alright, so we're looking at adults and students coming to this movie, and we have the total number of people attended, total price here, and we've got costs of adults and costs of students, and they're asking for how many students attended, how many adults attended. I'm going to use A for the number of adults, and I'm going to go ahead and use C, since that doesn't look like a 5 if I used S, for number of students. And we're ready to set up the problem. A plus C, so the number of adults, number of students add together to make 580, and that's what it says right here. 580 tickets were sold. And then I have the costs. So $6 for an adult ticket, $4.50 for a student ticket, and the total amount was $29.70. So now we're ready to solve by using elimination. Would probably be the best method here. So I'll multiply by negative 6. It just makes the math a little easier. And that leaves me with 3,480 is what 6 times 580 makes. And when I go ahead and add these together, I'm left with a negative 1.5c. And this all equals negative 510. So when I go ahead and do the division, negative signs should cancel, and always look for that. Make sure your signs are canceling. You should have a positive number of people, and the number of students is 340. And so all I have to do to find out the number of adults is just subtract that amount, that 340, from the total of 580. And so when we do that subtraction, I'm left with 240. So 240 adults, and we had 340 students show up. And so moving on to the next problem here, it says Brian and Kathy drove a total of 447 miles in 9 hours. Now these are totals, and so we'll have to use that concept to help us write some equations. Brian drove the first part of the trip, averaged 65 miles an hour. That's going to be important. Kathy drove the remainder, averaged 45 miles per hour. So for what length of time did Brian drive? Okay, so once we want to find out, once we go to what they're asking for, that's going to tell us where our variables go. So we've got distance equals rate times time. That's the formula we're using. So now we're just going to write two equations, one for Brian and one for Kathy. And so my Brian equation is going to go this way. I don't know how far Brian drove, so I'm going to call it D. I know he drove 65 miles an hour, and I do not know how long it took him, so I'm going to put t. Now, the reason I put those variables there is because that's what we're trying to find, Brian's time. So now, Kathy, we're going to go ahead and write an expression. See, this is a total, 447 miles. So if I take that 447, subtract Brian's distance, that's going to give me Kathy's distance. Take her rate, 45 miles an hour, and multiply it by the time she must have driven, which would be 9 minus t. See, Brian's time, take that away from the total time. So now we're going to go ahead and use substitution. Take the 65t, put it in for d, because that's Brian's distance, and we'll go ahead and subtract that from the total distance. And this all equals, we have 405 when I multiply the 45 times 9, then minus 45t. So now we're ready to solve. I'll just subtract that 405 from both sides, add the 65t, get the t's onto one side, and I'm left with 20t equals 42. And so when you divide by 20, you end up with 2.1 equals t. And so that would be 2 hours and 1/10 of an hour, or you could say 2 hours and, in this case, 6 minutes. If I took, the way I got that 6 minutes is I went 0.1 times by 60, gives me 6 minutes. And so that's where that came from. So that's the time in which Brian drove for. So now we've got a distance, another distance rate times time problem. I'm going to call r is going to be the plane speed, and I'm going to use w for the wind speed. So looking at this problem, it says that the plane flies 900 miles with a tailwind in 3 hours. Okay, so let's write that out. Distance equals rate times time. We've got 900 miles, and the rate, since it's a tailwind, the wind is pushing the plane. So we're going to go r plus w times by 3 hours. That's how long it took. Well, against the same wind, it took 5 hours. So same distance, but against the wind means r minus w. So there's a quick way to solve this. I'm going to go ahead and divide by 3 on both sides. Here I'm going to divide by 5 just to cancel out these 5s, cancel out these 3s, make the problem a little bit easier. So what that leaves me with is still have this 300 now, 3 into 900 equals r plus w. 5 into 900 gives me 180, and it's r minus w. And see, the reason I did that is I get the w's to cancel here, and so I'm left just with 2r equals 480. So when I divide by 2, I get the answer. 240 miles per hour is the plane's speed in still air. So those are the problems that you're going to see on this week's test. Good luck.